Hello students, Re-NEET is wonderful opportunity for most of the students. Students, don't lose this opportunity, gear up. Our MS Education Academy expert NEET team is there with you. Inshallah, we will be guiding both offline and online. You can connect to us anytime on WhatsApp, students. So to support you, our lecturers are making video bites of important bits so that you can anytime watch that video and get clarified your doubts and get enlightened. Students, we are there with you. Please do not lose this opportunity. All the best.
Hi students. So we know chemical bonding is an most important chapter for any entrance examination. NEET, they're going to ask minimum 4 to 5 questions. So today we'll discuss most important NEET questions from chemical bonding. Also most expected also you can say. So then first question if you see, if bonded molecule MX3 T-shape, the number of non-bonding pair of electrons. So even this question, this time NEET also asked it. So if you go for T-shape, so whenever T-shape means you can take best example ClF3. So best example if you take it as here. So this is my ClF3 molecule. So chlorine is a central atom. This is my chlorine. Chlorine has 7 electrons on the central atom. Then your given molecule has 3 fluorines. This is fluorine. So again this is fluorine. This is fluorine. That means ClF3 molecule has 2 lone pairs and 3 bond pairs. It has a T shape. That means it has 2 non-bonding electrons. So non-bonding electrons also you can call 2 lone pairs. That means my correct option is option B. So second option you can take. Then if you go for next question. So which of the following does not show paramagnetism? I'll give you super trick to answer question based on paramagnetic nature and diamagnetic nature. I repeat, if any molecule, total number of electrons, equal to odd number, directly you can go paramagnetic. I repeat again, if any molecule, total number of electrons equal to odd number, directly you can go to paramagnetic in nature, or else you can say diamagnetic in nature. If you see NO2, nitrogen monoxide, this is NCERT in-text question, most important. NO2 molecule, total number of electrons, it has odd number of electrons, it is a paramagnetic molecule. How to find? Yeah, nitrogen 7 atomic number, I have 2 oxygens, 8 plus 8. That means total number of electrons, if you see 15 plus 8, it becomes 23. 23 is an odd number. Then if you go for NO, 7 plus 8, it equal to 15 electrons. 15 means again odd number. This is paramagnetic. NO, special, neutral oxide, NCERT cover page. Then if you go for KO2 you can call superoxide. So special word, superoxide has a 3 electron bond. I repeat again, superoxide special word, it has a 3 electron bond. So KO2 superoxide, your total number of electrons, again you can count here, potassium 19. So oxygen 8 plus, again 8. No doubt it has an odd number. Again you can say paramagnetic nature. Then option D, Na2O, sodium oxide. If you see here, sodium electrons 11 plus. Then if you go for here 8 electrons it has. No doubt it is not an odd number, even number. That means no doubt NaO2 is an diamagnetic molecule. So except NaO2, rest all are paramagnetic. I repeat again, any question based on diamagnetic or paramagnetic, directly you can go to, if total number of electrons odd number, you can say paramagnetic. Even exception O2 molecule is paramagnetic. So now in this question, right option is fourth option. Option D you can take. Next question if you see, which of the following molecule which does not have 2 lone pair of electrons? I repeat again, which of the following molecule which does not have 2 lone pair of electrons? Now if you go for valency cell electron pair repulsion theory, this is my oxygen here. Oxygen is my central atom. So oxygen has 6 electrons in the outermost shell. I am taking 6 electrons here. Then I have 2 fluorines. Each and every fluorine can form 1 bond. That means it has then 2 lone pairs. it has an 2 lone pairs and 2 bond pairs. So due to presence of 2 lone pairs and 2 bond pairs, it has an angular shape. It has an angular shape. The question what asked does not contain 2 lone pairs. It has 2 lone pairs. Now second question if you see, second option if you see ClF3. This is my ClF3 structure. Chlorine group number 7. I have taken 7 electrons. So this is my fluorine. This is my fluorine. This is my fluorine. No doubt again it has 2 lone pairs. It has 2 lone pairs. That means this is not correct option. Now if you go for xenon tetrafluoride. Yes, this is my xenon. Xenon group number 8. So what is the special of xenon? Among the noble gases, xenon only reactive. Why xenon only reactive? Xenon has low ionization potential. Due to presence of low ionization potential, xenon only will form oxides and fluorides. So this is my xenon, group number 8. I am taking 8 electrons here. That means 4 fluorines given. The formation of bond, formation of bond, formation of bond, formation of bond. Yes, it has again 2 lone pairs, 4 bond pairs. This is not a correct option. Now if you go for SF4, SF4 special sulfur belongs to 4th group. This is my sulfur. Sulfur valence electrons if we take 6 here, that means there is a formation of fluorine, 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 fluorine bond. Yes, no doubt. SF4 has 1 lone pair and 4 bond pairs. It has an seesaw, sp3d hybridization. It has an sp3d hybridization, seesaw. Correct option is option D. So I repeat again. Another extra information for you, SF4 has dipole moment. If any question asked about dipole moment, if any molecule has at least 1 lone pair at central atom, if any molecule has at least 1 lone pair at central atom, that molecule has dipole moment, except xenon tetrafluoride and xenon difluoride. All the molecules having at least 1 lone pair at central atom, they have a dipole moment. Now in this question, correct option is SF4. Now if you go for next question, yes. So in O2 molecule, yeah, this question is most important. So in O2 molecule, which of the following molecule orbitals are low in the energy as compared to sigma 2pz orbital? We have a MOT. So MOT proposed by Millikan. By using Millikan's MOT, we can find the paramagnetic nature of molecules. We can find the bond order of molecules. We can find the bond length of molecules. We can find the stability of molecules. So as per this theory, we can find the, by using MOT, I am saying, by using MOT, we can find the magnetic nature of molecules. We can find the bond order of molecules. We can find the bond length of molecules. We can also find the bond energy of molecules. We have a simple relation. We have a simple relation based on this theory. As the bond order increases, bond energy also increases. As the bond order increases, stability, S means stability, stability of molecule also increases. As the bond order increases, bond length decreases. So I repeat, as per this theory, if any molecule has bond order equal to 0, if any molecule bond order equal to 0, that molecule does not exist in nature. As per this theory, if you see bond order equal to 0, that molecule does not exist. Best example, 4 electron, 4, for example, you can take 4 electrons like a He2 molecule, then 8 electrons like a Be2 molecule, 20 electrons like a Ne2 molecule does not exist. These molecules does not exist as per this theory. I repeat again. So by using MOT, we can find the bond order, we can find the paramagnetic nature, we can find the bond length, we can find the whether molecule exists or not. So I repeat, as per this theory, molecules having 4 electrons, 8 electrons, 20 electrons does not exist. So now if you go for given question, just we can go for Millikan second rule. Just we have a formula sigma 1s2 while writing electronic configuration, sigma star 1s2, sigma 2s2, sigma star 2s2. Then you can take it as a sigma 2p Z, sigma 2pz, then you can take pi 2px equal to pi 2py, 2 electrons, 2 electrons, 2 electrons. Then you can take pi 2px star equal to pi 2py star. It has 1 electron, 1 electron. This is the electronic configuration of O2 molecule. In the given question, if you see asking what, see, the energy, lower energy than sigma 2pz orbital. That means if you see, no doubt at all, sigma 2pz orbital here, this is my sigma 2pz orbital. So as compared to sigma 2pz orbital, these orbitals have low amount of energy. So that means what? It can be sigma 1s, so it can be what? Sigma 2s, and also what? It can be sigma star 2s. That means my correct option is, you can take it as a 213. You can take 213 is the correct option. 213 you can take correct option. So I repeat again, if any molecule has total number of electrons odd number, you can call again paramagnetic, except O2 molecule. So if total number of electrons even number, you can call diamagnetic. So then if you go for the next question, the number of water molecules directly attached to one water molecule is, yes, this question most important. So in your chemical bonding chapter, if you see, this is based on hydrogen bonding. So what is mean by hydrogen bonding? Simple trick to identify hydrogen bonding. If any molecule has OH bond or NH bond or FH bond, the type of bonding you can call hydrogen bonding. Hydrogen bonding means only these three in the syllabus. So due to presence of hydrogen bonding, molecules will show abnormal boiling point. So due to presence of hydrogen bonding, boiling point increases. So no doubt water has an hydrogen bonding. In the liquid state, 1 mole of water molecule, surrounded by 4 moles of water molecules. So due to formation of intermolecular hydrogen bonding, due to formation of extensive hydrogen bonding, that means if you see 1 mole of water molecule is directly surrounded by 4 moles of water. So correct option should be option D. Option D is the correct option. So I repeat again, in liquid state, 1 mole of water molecule is surrounded by 4 moles of water molecules. Correct option is 4th option. That means 4 you can take. So next question, if we move, the number of, so next question, if you see, the bond angle in pH3 molecule. So this question from 50A group elements. So in 50A group elements, no doubt in 50A group elements or 60A group elements or 7th A group elements, top to down in hydrides, top to down, if you go for top to bottom, so bond angle decreases. No doubt ammonia has high bond angle 107. So as compared to ammonia, pH3 molecule has low bond angle. That means correct option should be a bond angle of pH3 molecule is lesser than ammonia. So correct option should be, I'll give you one trick to remember here. Also questions based on here, they're asking boiling point of hydrides. So I'll give you super trick to find answers. Just remember trick B snap. B snap is a trick to find B snap. So B snap is a trick to answer question based on boiling point of hydrides. So what is mean by B snap? How to apply? Yes, B snap means B means bismuth hydride, S means antimony hydride, N means ammonia, S means arsenic hydride, P means phosphine. So this is a trick to remember boiling point of hydrides from 5th group hydrides. Maybe this question they can ask, NCERT in-text question, most important. So B snap trick to answer boiling point of 5th A group hydrides. Now if you go for the next question, Yes, the correct order of dipole moment of hydrogen fluoride, H2S and water molecule. No doubt. What is mean by dipole moment? So by using dipole moment, you can differentiate whether molecule is polar or non-polar. So if any molecule has polar nature, that means any molecule has dipole moment, that molecule you can say polar covalent compound. So if any molecule dipole moment 0, that molecule you can say covalent compound. So what is mean by dipole moment? The product of magnitude of charge, and the distance between two ions. The product of magnitude of charge and the distance between two ions in a covalent molecules, we can say dipole moment. So I repeat again, dipole moment depends upon electronegativity and bond length. More is the electronegativity, more is the dipole moment, more is the bond length. Generally, as the bond length increase, dipole moment increase, but not always. It is also depends upon electronegativity. So generally here if you see water is a polar molecule, no doubt at all. When HF also polar molecule, no doubt. Even H2S also you can say polar molecule, no doubt. But here as compared to HF, water has high dipole moment. The dipole moment of water molecule is 1.85 dBi. The dipole moment of HF molecule is 1.82 dBi. That means as compared to hydrogen fluoride, water has high dipole moment. Even some books given HF has high dipole moment, but the dipole moment of HF changes. But if you see water, correct option is water has high dipole moment. Then see water has high dipole moment. Then if you go for, see this is the correct option here. So number 1 is water. You can go with this option. Generally here given option if you see, I repeat, number 1 is water you can take, number 2 you can take H2S gas, number HF you can take, least you can take it as a H2S. But some books also given HF as more, but this is the correct option. So you can go with water, HF, H2S. So next question if you see, yes, if two atomic orbitals combine, the energy of bonding orbital is lower by x, while that anti-bonding orbital, I repeat again, this question based on VBT, valency bond theory. So valency bond theory, if you go for valency bond theory tells us, okay, valency or MOT tells us formation of bonding only. Always remember, bonding orbitals are more stable than anti-bonding orbital. That means energy point of view. So anti-bonding orbitals have high amount of energy, bonding orbitals have low amount of energy. That means if you see here, X is generally the bonding orbital lower by, yes, correct Amma, correct if you see, that means here anti-bonding Y. That means energy point of view, Y as maximum energy than X. So as per energy, anti-bonding orbital has high amount of energy than bonding. As per stability, bonding orbitals are more stable than anti-bonding. So correct option should be Y greater than X. Second option you can take. Then if you go for next question, in the formation of I3 minus, another most important question, in the formation of I3 minus, Lewis bases. So then if you go for I3 minus, the formation of I3 minus, it is in the I2 plus I minus combines to form I3 minus. So then if you see here, I minus act as a Lewis base. So correct option is option D, I minus. Even after formation of I3 minus, it can dissolve in water. I repeat, before I2 insoluble in water. After adding I minus, it become polar. It can dissolve in water. This question is most important.